In this lecture, we're going to zoom in on declarations and definitions in your C++ code, and we're going to think about the meaning of these words in your C++ program. A declaration is something or a statement that is going to introduce a name in your C++ program. A definition says what that name is or what that name does. I know this sounds a bit confusing right now, so let's look at an example. Here we have a piece of code in which we have a function declaration and we have a function definition below. The function declaration is giving up some information about this function. For example, we know that this function is not going to return anything. We know the name of the function, but we don't really know what this function is going to do. And this is really what the splitting between declaration and definition is all about. Somebody might not be interested in the full details of your function, and they are just going to use the function declaration. This is going to introduce the name, some function in our code. So if we refer to it, the compiler is not going to complain. So we have successfully introduced a name in our program using this declaration here. Again, a declaration is some kind of statement in your C++ code that is going to introduce a name in your code. If you want the full details about that name, for example, knowing what that name does or how it does what it does, then you will need a definition for your thing. If you look down below here, we have a definition. This is the code that is going to give up more information about this function here. For example, if we have something in the body of this function, we will be able to see it and we will exactly know how this function does its job. And this is a function definition. Again, the definition is going to give up more information about what the name does. In this case, the name is some function here, and how the name does what it does. This is what we really mean when we say we have a declaration of something or we have a definition of something. Let's look at some things you need to be careful about in terms of definitions and declarations. If a name is never used, for example, a function is called or a variable is used in any way in your C++ program, its definition won't never be needed because we won't need those details because the name is not really used in your code. So the code will just compile and work fine even if the definition for that name is not in place. If we look at the second point here, we're going to say if you compile without a declaration and the name is used, you get a compiler error. And we're going to get some kind of name is not defined in this scope or something like that. So for your name to be used in any way, you need a declaration in place. And we're going to see an example of this in a minute when we hit Visual Studio Code, but you need to keep this in mind. If we look down here, we're going to see that if you compile with a declaration without a definition and the name is not used, the code is going to compile. So you have a declaration, you don't have a definition, but the name is never used, so the code is going to compile. If we look at this line here, we're going to say if you compile with a declaration without a definition and the name is used, you're going to get a linker error because the definitions are really resolved at the linker stage. So you're going to get a linker error. And we saw an example of this in a previous lecture when we split our compilation into two steps, compilation and linking. Okay, so now that you have these ideas in mind, we're going to look at declarations and definition strategically. We are going to look at these concepts in the context of freestanding variables. We're going to look at them in the context of functions, and we're going to look at them in the context of classes. Let's start with variables. Here we have a single variable. It is really simple. Its type is double. The name is weight, and it is initialized to 0 using braced initialization here. The statement here is going to double as both a declaration and a definition because it is introducing the weight name in our C++ program. For example, if we're trying to print the weight, we're going to get it printed out. We're not going to get a compiler error saying we don't know what weight is because we have introduced this name using this declaration here. But this is also a definition because it is really saying what this weight is. It is a variable of double type and its value is 0 because we initialize this using brace initialization. So this is a definition and a declaration at the same time. I have to say that it isn't really common to separate declaration and definitions for variables, and I don't really know how you would even do that. So we usually do this way by combining declaration and definitions for variables. But for some variables, for example, static variables that are inside classes, it is possible to separate declaration and definition, and I am going to show you that in a minute when we hit Visual Studio Code. But note that in most cases for freestanding variables, the declaration and definition are combined in one statement, as you see here. For functions, it is possible to separate the declaration and definition. For example, what we have here is a function declaration. It is introducing this name in our code, but we don't really see how this function does its job. And if we want to see that, we will need to look at the definition for this function here. Down here, you see we have the definition for this function. This is a definition, and we have the body of the function, and in the body, we can really see what this function is doing. So this is a function definition here. For classes, for example, using the example here, this is also going to double as a declaration and a definition. It is a declaration because it is introducing the point name in our code. For example, we can create point objects and that's going to work. The compiler is not going to be confused. It is a definition because we really have all the information to know what this type does. If you create it, you're going to have the values stored in your member variables, and we have all the information about a point type in our code. So this is also a definition. Here is another example for classes, but we are using the class keyword here. We're not using struct like we did in the previous slide. This is also going to double as both a definition and a declaration. It is a declaration because it is introducing the person name in our code. We know what it is, so it is a class. But it is also a definition because we really have all the information here. We know its member variables, we know its constructor. So this is a declaration and a definition at the same time. But know that it is possible to separate the members of a class into declaration and definition, and that definitions might show up at the outside of the class, and we're going to see how you can do that in a minute. Okay, so this is really all I wanted you to know, the concepts of declarations and definitions in the context of variables, functions, and classes. Now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is declarations and definitions. We're going to grab our template files and put them in place. Let's do that. And we are going to open this in Visual Studio Code pretty quick. This is going to give us our main CPP file, and we can clean up a little bit. So this is what we have. The first thing we're going to do is play with freestanding variables. We're going to go on top here and declare a weight variable like we had in the slides, and we're going to initialize this guy to 0. And one thing you should know is that this is going to double both as a declaration and definition. It is a declaration because it is introducing the weight name in our program. So for example, if we go down and try to print out the weight, this is going to be valid C++ program. The compiler is not going to wonder about this name here. It was introduced in our C++ program. It is also a definition because we really know what is inside this weight variable. We know that it has a value of 0. So this is both a declaration and a definition. If we build and run this program, it is going to work because it is really a valid C++ program. We can bring up a terminal and run it. No, we don't want that. We want a terminal. So let's run Rooster, and we're going to see that this program is going to print 0 because that's what we have in here. If we happen to put in an 8, for example, 8.7, why not? We're going to build again, and we're going to have our value in. If we run Rooster, we're going to have our value in here, and it is going to be printed out. So this is a declaration and a definition. Please note that in most cases, variables are going to be set up like this, combining declaration and definitions, but it is possible, especially for static variables in classes, to be split into declaration and definition. If you ask me to break this into declaration and definition, I wouldn't really know how to do that. If you happen to know that, please share. I am interested. But in most cases, we're going to declare and initialize variables in one go like this. And this is going to double as a declaration and a definition. Somebody is going to say, what if I do something like this and maybe assign a value to the weight here? Let's do this to really remove this confusion. For example, you do something like this. They're going to say, maybe this is a declaration and this is a definition. I hate to break it to you, but this is also a definition like we had before, because this is going to initialize weight anyway. So this is going to initialize weight to a junk value, but it is going to be initialized. So this is going to still be a declaration and a definition. And here what you will be doing is just assigning to a variable that's been already set up, declared and defined. So this is just an assignment here. You should know that. Okay, so if we comment this out, you're going to see that the compiler is going to accept this. The code is going to compile. Let's do that. You're going to see build is good. And if we print whatever is in weight by running our program, as you see here, we're going to get a junk value. And this happens to be 0 in this case. So this is a declaration and a definition for freestanding variables. Now, let's talk about functions. If you set up a function like this, for example, we're going to say add, we're going to say double, and we're going to add up two parameters. We're going to say A and B, and you do something like this, and you return, for example, A plus B. This is going to double both as a declaration and a definition. Because we have the body of this function here, we know what this name is. We know it was introduced in our program, so it is a declaration. But we also know what this function does. It is going to add up two parameters, and we know how it is going to add up those parameters because we can see the statement that is doing exactly that. So this is also a definition. But know that it is possible to break functions into declarations and definitions. Let's comment this out and show you that option here. And I'm going to leave this in as a reference. We're going to grab the signature of this little guy, and we're going to make it the declaration. Let's do this. We're going to put this in, and this is going to be our declaration. You already knew this, but I really want this to be super clear. We can now take this declaration here and go down and use it a little bit and set up a definition. We can do that. What we have below here is going to be our definition. And we can go inside and do whatever we want to do in this function. And in this case, what we want to do is to add up A and B and return the result. So this is going to be our function here. And if we call it, it is going to work. If we go down here and say double result and say add 10 to 20, we have done this 1,000 times, but we're going to use this example again. We're going to print the result, and we're going to print this out. If we build and run this program, it is going to work because we have a declaration that is introducing this add name in our program, but we also have a definition that is saying how this function is doing its job. We can see that right here. So if we build this program, we're going to use GCC like we always do. We're going to clear, the build is good. If we run Rooster, we're going to see results to be 30. And if we change this, for example, to be 20.5 and build again, just to make sure that this program is working and I am not making this up, we're going to see 30.5. So this is adding up what we have here. One thing you should know is that if you don't have a definition in place for functions, you're going to get a linker error. Let's do that. We're going to comment out this definition and we're going to try and build again. And you're going to see that we're going to get a problem. We're going to see build finished with errors. And what we have here is an undefined reference to add. So this is a linker error. It is a linker error because we can see LD returned one exit status here. But in a previous lecture, we also saw that we could split compilation in two steps, compilation and linking. And we saw that you could see these linker errors if you don't have definitions in place. So this is one way you can split your functions into declarations and definitions. It is also possible for the definition to live in some other file. So let's bring up our sidebar here and create another file. We're going to call it some other file. Why not? And it's going to be a CPP file. What we're going to do is move our definition there. So we're going to copy it. Let's copy what is inside the comment. So we're going to copy this and we're going to put this in some other file here. And the linker is going to be smart enough to search this entire directory looking for the definition of this function. Now, if we compile, you're going to see that the definition in main is gone, but we have a definition in some other file. Now, if we try to compile the program again, it is going to work because we have a definition in. You're going to see that the world is good because we have this definition here. And now if we run the program, let's clear and run Rooster, we're going to see that it is going to work because we have a definition in place. Another thing we're going to look at is declarations and definitions in the context of classes. So let's create a structure here. We're going to do a struct and we're going to call it point, like we have been doing all along. Inside, we're going to have two member variables. We're going to have mx and my to represent the coordinates of our point type here. And I hate to break it to you, but this is also going to double as a declaration and a definition. And in most cases, you're going to see things like this called definitions. They're going to say it's a class definition and it's going to do this and that. So this is going to be mostly called a definition, but note that it's doubling as a declaration and a definition. It is a declaration because it is introducing the point name in our C++ program. It is a definition because we really have all the information we need to know about this point object. It is going to store its member variables in mx and my, so we really know all we need to know about this little guy here. If you also set up a class, it is going to double as a declaration and a definition. I am going to grab a class I have lying around on my system and I am going to put it in here because I don't want to type all this. We have a class called person. It has a constructor here and we don't have a body of this constructor n, so we can put it in. We're going to say full name and we're going to pass in names param. We're going to use braced initialization and we're going to do this on a separate line. I think that's going to be much cleaner. And we're going to do age and we're going to put in age param here. And we're going to put in a body for this function here. I think this is all we need for this to be valid C++ code. So this is our constructor. We have a function to print information about a person object and we have our member variables here. Notice that we also have a static variable in this function here. So it will need to be initialized in some other CPP file. And we can do that using a statement like this. We can say person, and we're going to say person count because it is a static variable. We are going to specify its type, and then we can initialize it to a value, for example, 8. We can do something like this. From this, you should note that for this static variables, what we have inside the class here is a declaration. So you should note that. But the entire class here is also a declaration and a definition in one go. So in most cases, things like this are going to be called class definitions, but note that they also double as declarations. But it is possible to take member functions of classes and split them into declarations and definitions. Declarations are going to live inside the classes, but definitions can be put to the outside of the class. And we're going to show you an example of that using the constructor here. So we're going to take out the initialization we have here, and we're going to leave in a declaration. So we're going to do that. This is going to become a declaration for the constructor. And we're going to put the definition at the outside. So we can go down here, for example, and say person, and we're going to put the body of our constructor down below here. Now this code is going to work. And if we create a person object, we can go down here. I think we can comment out all we had before because it has served its purpose. It is now confusing us. So let's do that. We're going to comment all this out. We're going to go down and create a person object. We can say person P1 and we can give our person a name and an age. I think we can do that. Let's see. Yes, we can do that. We can pass a first parameter as a name. We're going to say Jon Snow. And we can give them an age, let's say 27, why not? And we can print information about this person. We can say P1 printful. And if we build and run this program, I think it is going to work. Let's bring this up a little bit. You see the build is good. We can clear and run Rooster, and we're going to get name, age. And if we want, we can also print the static variable here, but we don't really want to do that. Okay, so now you know that a class itself is going to be a declaration and a definition, but for the member variables of the class, it is possible to split them into declarations and definitions. One thing I want you to see is that we can also move these things out. For example, the class here, it is cluttering our main CPP file. So what we can do is come back to the left here, bring up the sidebar. We can create a header file for it. We're going to say person.h, and then we are going to put in our include guards. We are going to put them in here, and we're going to go down and say and if. I can't really remember these things. And we're going to say that this is for person h, and then we're going to grab the class. We can copy it. Let's do that. We can grab the class here, and we're going to put that in its separate file. We're going to do that, and we can come back in our main CPP file and now include the person. We're going to do that. We're going to say include person.h. And I think we should also move the definitions for the static variable and the person constructor in a separate file. Let's go back to person and see what problem we have here. What did we have in main? We had IOStream, so it is complaining that it doesn't know stdc out and the string. Let's go on top here and include IOStream. Let's do that. It should stop complaining here. Let's wait a minute. So this is all good. If we go in main, we see that we have no problem. If we compile our program, it is going to work. We're going to see that the build is good, even if we have our class definition in a separate file and some definitions in the CPP file. You see that we have the definition for our static variable in main. We have the definition for the constructor in main. But it is really not cool to have these definitions in main. So we can also take them and put them in a separate file. For example, we can move them in some other file here. We're going to put them in here. Okay, you see that the moment we do this, we're going to get these errors because this file doesn't know what person is. So we're going to go on top and include person. And now we shouldn't have a problem with this. Now the IDE or the editor is happy. We can build and run this, and you're going to see that it is going to work. And this is really all I wanted you to see in this lecture, that you can split things into declaration and definitions. And we really tried our best to explain the difference between declaration and definition in the context of freestanding variables like we have here, the weight variable, functions like the add function here, and classes using point and person here as an example. And we saw that we could really split things between files once you understand the difference between a declaration and a definition. Definitions can really live in any files. You have seen that the definition for the constructor here and the definition for the static file could really live anywhere. We were able to compile our code with these definitions in main. We are able to compile our code with these definitions in this file here. And this is really cool. Okay, before I wrap up this lecture, one thing I want you to see is that if any of these definitions is not in place, you're going to get a linker error. And to really prove this, we're going to comment out the definition for the constructor of our class here, and we're going to try and build our program. We're going to build this with GCC. Let's do that. And you're going to see that we get an error, and the error is saying undefined reference to person. So we don't have a constructor here. Even if we have a declaration in our class here, you can see that it is not enough. The linker is going to complain because it needs to know how to construct person objects. So we can come back and bring this back in, and if we build, this is going to work. So we're going to run with GCC, and the build is going to be good. If we also don't have this definition for person count, if we build the program, it is going to build and run fine because we're really not using this static variable in our program. And let's build to show you this. And we're going to see that the build is good and the program can run. We can clear and run rooster. This is going to do whatever it is we want to do. But if this static variable is used anywhere in this class, for example, when we create a person object, we increment the person count. This is a logical thing to do because this is keeping track of how many person objects we have. If we try to build this program now, we are going to get an error, and that's going to be a linker error saying undefined reference to person count. But we have person count declared in our class here. So some of you might be thinking, what the hell is going on here? But this is a declaration. It is not a definition. And the linker really needs a definition to know what this variable is. So we need to go back in whatever CPP file where we have our declaration, and we need to bring this back in. And if we build now, we're going to see that the build is good and everything is working as expected. So I really want you to know that definitions are important for your program to run. And this is really all I had to share in this lecture, shedding some light on declarations and the definitions in the context of freestanding variables like the weight variable here, functions like the add functions, and classes like point and a person, as we have seen in this lecture. We are going to stop here in this one. In the next lecture, we're going to learn about the one definition rule. Go ahead and finish up here and meet me there.